Hello students. Today we are going to do the notes 2-9, Systems of Linear Inequalities. 2-9, Solving Systems of Linear Inequalities. The objective: the learner will graph systems of linear inequalities and decide if points are solutions to the system. Two or more inequalities using same variables are called a system of linear inequalities. The points that make both inequalities true are located in the region that is shaded twice. Finding the solution to a system of linear inequalities, we have three steps. First, we want to graph the solution set of the first inequality, which if you refer back to notes 2-7 to help you out. Then we'll graph the solution set of the second inequality on the same graph, and once we have them both graphed, the solution set is going to be the region that is shaded twice. Our example, we're going to solve the system of inequalities by graphing. We can tell that this is a system because we have two inequalities. So in order for us to graph these, though, they must be in what we call slope-intercept form. So I'm going to take this top equation, which is y plus 2x is less than or equal to 4, and I'm going to go ahead and isolate the y, or get y by itself. To do that, I'll subtract 2x from both sides. Cancels this out, so I get y is less than or equal to a negative 2x plus 4. Then we have to look at the second one and see if that one has y by itself, and it doesn't. So we need to move this negative 2. So we will divide everything by negative 2. And if you remember, or refer back to the rules, if we ever multiply or divide by a negative, so since this bottom number here is a negative 2, we have to flip our inequality. So our inequality is going to go from less than to greater than. These 2's will cancel out, leaving us with y. These 2's right here will cancel out, and the two negatives will become positive, and 2 divided by 2 is 1. So we get 1x. And a positive 3 divided by a negative 2 will become a negative 3/2. So now we have our two linear inequalities put into slope-intercept form, and so now we can graph those. Alright, so I just made the graph a little bit bigger here and wrote down our inequalities in slope-intercept form. So we're going to go ahead and graph the red, or our first inequality, which says y is less than or equal to a negative 2x plus 4. And when we go ahead and graph these, we need to make sure that we always start with the y-intercept. So right here we see plus 4, that is b, our y-intercept. So we'll go on the y-axis, we'll go up 4, and we will go ahead and place that point right there at 4. Then we need to go ahead and use the negative 2, because that is our slope, and we can say that that's negative 2, or we can say it's negative 2 over 1, which means from 4 we're going to go down 2 and right 1. So I go from the location, or the point at which I started, go down 2 and to the right 1, and go ahead and place another point. And if I want to continue, I can continue going down 2 and right 1 and keep putting some more dots there if I want, or some more points, but I don't have to. Once we do that, we need to then take a look at our inequality. So we can see here that our inequality is a less than or equal to. And from our notes from 2-7, we should know that if it is equal to, it needs to be a solid line. So we will go ahead and draw a solid line. And then it says that y is less than or equal to a negative 2x plus 4. So what that means is all my y values are going to be smaller than the expression negative 2x plus 4, or the line that we drew. So we go ahead and we look at it and we can shade below or down and shade all of that area in there. That is y is less than or equal to a negative 2x plus 4. Alright, so let's go ahead and let's look at the blue, or the second inequality. It is y is greater than 1x minus 3 halves. So we always start with b, which is a negative 3 halves. And if we wanted to change that to a decimal, that would be a negative 1.5. So we'll go down on the y, down 1, and then just in between 1 and 2. And then we will go ahead and find our slope, which is m, which is 1 over 1, which means you're going to go up 1 and right 1. So from the negative 1/2, we go up 1 and to the right 1, and then up 1 to the right 1, and you can see I can start making that line there. Now before we graph our line, we need to look at the inequality here. This inequality does not have a line under it because it is y is greater than. So since it is just greater than, we need to use a dashed line. So we will go ahead and just draw our dashed line through there. And it says y is greater than 1x minus 3 halves, or all of my y values are going to be larger than the expression 1x minus 3 halves, or bigger than the line, or we can also say above the line. So we would go ahead and shade all of that. Now we have both of our inequalities graphed on the same graph, so that makes it a system since it's 2 or more, and the solution is anything in the double shaded region. So you can see here where my red and blue come together, so right in here is going to be my double shaded region. So anything inside there is going to be considered a solution to this system of inequalities. Alright, that completes 2-9. These notes were fairly short because they're basically the same as 2-7, where we just graphed a linear inequality, only with a system we have 2 or more, and so it's just graphing just like 2-7, one inequality, then you just graph the second one, and the double shaded region is going to be your solution, anything that lies inside of there. So if you have any questions or anything, please make sure that you ask your teacher in the morning in tutorials or at the beginning of class, and make sure that you submit your WISC and completed notes to class. And we'll see you tomorrow. Thank you.